Find the critical values and rejection regions for the type of t-test with level of significance alpha and sample size n. Let's look at the first one together. We're looking at a left tail test. Alpha equals 0.10 and n equals 20. The first thing I'm going to do is I'm going to draw a picture. Since this is a left tail test, my critical value is going to be to the left of the middle, or the left of that middle value. So notice here that whenever I get my critical value, it's going to be a negative number. The area under the curve is going to be alpha. And the next thing I also need is a degrees of freedom. Remember that when you're dealing with the t-distribution, you're also dealing with degrees of freedom. The degrees of freedom is n minus 1. So in this case, it would be 19. Now let's go to our table, our t-table, and let's grab out our critical value. Here is my table 5 of the t-distribution. I'm dealing with 19 degrees of freedom. I'm going to use the one tail of alpha because this is a one tail test or a left tail test. And we said that our alpha is 0.10. So the t-value that corresponds with that is 1.328. Going back to the problem, remember that the 1.328 also needs to be negative. So this is negative 1.328. So that's my critical value. Now let's establish our rejection region. Remember that if I grab my t-test, my value for my t-test, and it falls in this region here, then I'm going to reject my null hypothesis. So we would say that the rejection region is when t is less than my critical value. Now let's move on to the second one. We're looking at a two-tail test. Alpha equals 0.05, and my sample size is 27. Again, I'm going to draw a picture first. Since this is a two-tail test, we'll have two critical values. One will be the negative, and one will be a positive. My degrees of freedom is 27 minus 1, or 26. Now let's go to our table and let's read off the critical value. Here's my t-table, and I'm going to scroll down until I see the degrees of freedom that I want, 26. Now, since this is a two-tailed test, we're going to use where it says two-tail. We're going to use that row. So my alpha was 0.05, so I'm going to scroll down, and the t-value that corresponds with that is 2.056. So this value here is negative 2.056. And this one is positive 2.056. Now let's establish what the rejection region is. Remember that the rejection region is going to be this area in here. If I plot my t-value or my t-test statistic and I plot it in that area, I'm going to reject my null hypothesis. So therefore, if your t is less than negative 2.056, or if it's greater than 2.056, we're going to reject the null hypothesis. So those would be my rejection regions. A used car dealer says that the mean price of a 3-year-old sport utility vehicle in good condition is $20,000. You suspect this claim is incorrect and find that a random sample of 22 similar vehicles has a mean price of $20,640 and a standard deviation of 1990. Is there enough evidence to reject the claim at alpha equals 0.05? Part A. Identify the claim and state the null and alternative hypothesis. First, let's highlight the claim. The car dealer says that the mean price of a 3-year-old sport utility vehicle is $20,000. Now let's write that in mathematical terms. the mean is $20,000. Notice that that's the key word, is. That means it's equal to. Now, because this has the equal sign, this is going to be the null hypothesis. The alternative hypothesis is the complement, which is not equal to $20,000. Part B, find the critical value or values and identify the rejection region. To figure out if this is a one-tailed or a two-tailed test, let's write out our alternative hypothesis. Since there is a not equal to sign, this is going to be a two-tailed test. So let's draw a picture of our standard normal curve. So you know that our critical values, we're going to have two of them. We're going to have one that's negative and one that's positive. Since we're dealing with the t-distribution, we also need to figure out what our degrees of freedom are. The degrees of freedom is n minus 1. Our sample size is 22. Therefore, our degrees of freedom is 21. Now let's take our degrees of freedom and alpha equals 0.05 to our t-table and figure out what our critical value is. Here's my t-table. I'm looking for degrees of freedom of 21, and this is a two-tailed test at alpha equals 0.05. Therefore, the critical value is 2.080. And remember, since it's a two-tail, one will be negative and one will be positive. Now that I have my critical values, let's establish the rejection region. Remember that the rejection region is going to be the tail region, or if we plot our t-test statistic in that region, we are going to reject the null hypothesis. Therefore, we can say that the rejection region is if t is less than the negative 2.080, or if t is greater than the positive 2.080. Part C, find the standardized test statistic t. The formula for finding our standardized test statistic is t equals x bar minus mu divided by the standard deviation, all divided by the square root of n. So let's plug in our numbers. X bar is the mean price that was from our sample. Mu is from our hypothesis. Our standard deviation is from the sample. And our sample size is 22. In the numerator, I find 640. And the denominator, that expression right there, simplifies down to 424.27. And this is going to be approximately equal to 1.5085. And if we round it to the nearest hundredth, we would have 1.51. Part D, decide whether to reject or fail to reject the null hypothesis. So first, let's write down our t standardized test statistic first. And now let's draw a picture of our standard normal curve and our rejection region. Okay, now I'm going to plot my test statistic on this chart. And when I plot it, I find it falls about right here. Notice that I did not plot it in the rejection regions. Therefore, I would fail to reject the null hypothesis. Part E, interpret the decision in context of the original claim. Let's look at the question again that's asked in my problem. It says, is there enough evidence to reject the claim at alpha equals 0.05? Since we failed to reject the evidence, we would say that there is not enough evidence to reject the claim. Let's look at this in writing. We would answer that there is not enough evidence at the 5% level of significance to reject the claim that the mean price of a 3-year-old sport utility vehicle in good condition is $20,000.